guys, this is our 14.5 video. We're not doing 14.4 because we didn't do it in class. And the first function we're going to be using is z equals 9 minus x squared minus y squared, where x is greater than or equal to 0 and y is greater than or equal to 0. And we're just going to do some basic housekeeping first before we get down into the problem. We're going to go ahead and find our partials, which f of x equals negative 2x, yeah? F of y is negative 2y, okay? And we want to find the surface area of the function. So surface area equals a double integral over region R of the square root of f of x squared plus f of y squared plus 1 dA. So let's go ahead and solve for our limits of integration. Z is this function here, so plug in 0 for z to get 9 minus x squared minus y squared equals 0. So y equals the square root of 9 minus x, which means our y limits of integration are going to go from 0 to this function of x. And then we plug in 0 for y and solve for x to get 3, which means our limits of integration for x are going to be 0 to 3. So we come back over here. X is 0 to 3, y is 0 to 9 minus x squared, square root of. So now we have to take the square root of our partial squared plus 1. This is going to be dy dx. And then I just kind of simplified that out. 0 to 3, 0 to this. And then our partial squared becomes 4x squared plus 4y squared plus 1 dy dx. And now we're going to convert this to polar. So we're going to come over here. In our original function, after we'd made z be 0, we had an x squared plus y squared equals 9. So our r squared is 9. And our r is the square root of 9, which is 3. So r is going to go from 0 to 3. And you can see that we don't have like negative functions here, meaning we only want half of this surface. So we're only going to go to pi instead of 2 pi. See, 0 to 3, 0 to pi. And then of 4r squared, because x squared plus y squared is r squared. And I just factored out the 4, put those together, and this is what it gave me. r dr d theta. Now doing some u sub, u is 4r squared plus 1, du is 8r dr. Our limits of integration go from 0 becomes 1, and 3 becomes 4 times 3 squared, which is 9, plus 1, which is 37. Which makes our integral be 1/8, 0 to pi, 1 to 37 of u to the 1/2 du d theta. And that becomes 1/8 times the integral from 0 to pi of 2/3 u to the 3/2 evaluated from 1 to 37 d theta, which becomes, if you multiply that 2/3 by the 1/8, 1/12 times the integral of 0 to pi of 37 root 37 minus 1 d theta, which gives us pi over 12, because once you integrate this, you're going to get a theta here and a theta here, which means pi goes to both, and you can just factor it out. So pi over 12 times 37 root 37 minus 1. And that is your final answer for that problem. Now coming over here to our other problem for 14.5, we have the function z equals xy, with x squared plus y squared equaling a squared, with a is greater than or equal to 0, and we want it in our first octet. So first we're going to do some housekeeping. R squared equals a squared, r equals a. And since we're in the first octet, we only want a quarter of what we would normally get. So we're going to have 0 is less than theta, or less than or equal to theta is less than or equal to pi over 2. So our f of x is y, which equals r sine theta. Our f of y is x, which is r cosine theta. And we're wanting to find surface area. So our limits of integration we already solved for. It's 0 to pi over 2, 0 to a. And then we have the square root of our f of x squared, which is r squared sine squared theta, plus our f of y squared, which is r squared cosine squared theta, and then plus 1 r dr d theta. And this gives us 0 to 2, or pi over 2, 0 to a, the square root of r squared plus 1, because I factored out these r squareds, and then it's sine squared theta plus cosine squared theta, which is 1. Okay, so plus 1, r dr d theta. Doing u sub, our u is r squared plus 1, our du is or 2r dr. And our limits go, 0 becomes 1, a becomes a squared plus 1. So this makes our integral be 1/2, because this 2 goes this way, and the r canceled out. From 0 to pi over 2, 1 to a squared plus 1 of u to the 1/2 du d theta, which becomes 1/3, because I multiply, or when I took the integral, this became 2/3 u to the 3/2, and 2/3 times 1/2 is 1/3. And integral from 0 to pi over 2 of a squared plus 1 to the 3/2 minus 1 d theta. And as you can see, our theta is going to distribute evenly, so we can just factor it out. So this becomes pi over 6 times a squared plus 1 to the 3/2 minus 1. And that is your final answer. If you have any questions, don't be afraid to ask me in the comments. I will look at them, and I will be happy to go back over anything that's causing confusion. I'm just trying to get all of this done before our test tomorrow. So I will be back with the next video shortly. See you guys.